Well, that's very good. Anyways, let's start. Hello, everyone. Welcome to the fourth, now I believe this is, weekly drop-in session. And what we're trying to do here is we're first and foremost here to answer your questions. And I did say that we have noticed that everybody seems to be sort of like, beginning to think about the technical questions that you want answered towards the end. Well, everybody's feeling comfortable now. It's like we've had all this chat, and Daniel basically has been chatting for an hour. Why don't we just start chatting between ourselves? So what I'm going to do right now is I'm actually going to mute my mic, because I will talk about what I want to talk about towards the end, and I want you guys to ask technical questions now. Something that it is in the back of your mind. Compost, soil food web, application rates, making compost. What about fungi? What about nematodes? What about this and that? Think about these things, and I'm going to shut up now. What's that?
Evening, Dan. How are you? Evening, all.
I'm very good. Who is that speaking now?
That's Damien.
Damien, how are you? Judith?
Who out there is actually applying stuff? I mean, of the group, who's actually doing something already? Am I the only one that's trundling about in a quad bike? In the rain.
Well, I've been doing trials with metabolites in strawberry and tomato crops with commercial growers in the country. So I'm not quite on my quad bike doing it, but we're sending material there.
So what are metabolites? I don't know.
Well, in this case, it's the. I mean, Daniel might be able to put more to bring this to into the mix, if you like. But from our point, I work for a company called Forward Food Tech, and we've got an algae product. So it's actually the liquid, the exudate that chlorella has been living in. So that's the algae, the green algae, and it's the metabolite, if you apply it to soil, it's acting as, and Daniel will talk to this, but it's acting in a way that it's just encouraging certain soil or organisms within the biome to respond.
So it'll be great. It'll be great to see. It will be great to see some data on that actual, what it's actually doing to the biology. But I think here,
and so
I've
got the data. I've actually got it. I've got the data now, actually, which we can share.
Send it over.
Yeah, we'll do.
Yeah, definitely.
They've just put a patent application in. That's why they've been able to release their data. I mean, and whether you need to also then on the back of that, then our view is whether it's substrate or soil is there has to be some other elements added to it, and that's Daniel's product and others potentially, but. It's an interesting area. So.
And did you find it had a positive effect on your strawberries? And
so most of the Dan, you happy for me to talk about this? Is that okay? Yeah.
Yeah, go ahead.
Well, literally just from a metabolite. The organization's based in Florida, and they've been trialing for 3 years on various crops in America, and in just about all regards, it's seen some kind of uplift, and it might not be the uplift that Daniel's experienced with spring barley. It might be literally a 5% year increase. That everybody claims to have 5%, but in the case of the guys from Florida, they've actually got particularly strawberries have responded very well so far. but that's soil-based, soil-grown. So it's really just helping within to do something specific within the soil margin. The question would be how it will work with substrates, Accoya in protected cropping, which is the interesting area that we're working on. And ultimately, Daniel, the work that he's doing will have great benefit to the substrate industry. So that's, you know, there's protected cropping sector, glass houses, polytunnels.
Who knows? So do you know what, Damien? The reason I'm not stopping you from, you know, talking about this alternative stuff, which is kind of could be treated as off topic, is because basically it's still a naturally derived product that might plug into a certain extent, and I don't know yet. So
exactly,
maybe in the future we'll do something. What I'm basically hoping that this is basically an opportunity for farmers who are already working with compost, for instance, to ask us technical questions about, you know, how to grow out the soil food web. So usually these questions come towards the end where everybody's so like well, can we just finish now? So that's why I'm trying to give this opportunity now, and I know it's making this uncomfortable silence because I don't want to be the driver of it, but Andy just unmuted.
Yeah, no, I follow the Facebook group like you do with the is it the Johnson soup, and there's discussion on there about whether we should be counting Hyphy or counting spores. Can you expand your thoughts on that one?
Yes, I mean, this is something that I think you would need more data on that, you know, between sort of the more third-party data, you know, like not just Dr. Johnson's data, because Dr. Johnson seemed to have this opinion that after 12 months you just don't have the Hyphy, that all of the resources have been used up and all you've got is spores. That is not a bad starting point for inoculants if, you know, you have these spores. If these spores are identified as beneficial ones, that's no problem. What we have seen basically is in material older than 12 months, we still had growing Hyphy, and some of our best material basically with Hyphy is that old stuff. And so there's nothing stopping us. Like Dr. Johnson says, you know, like, oh, don't bother counting Hyphy because you're not going to see anything. That's not true. And the other thing that points us to still counting Hyphy is last week's Niels's cheat, where he brought in his material. He sent us a sample of this material, which just in the material, not anything concentrated like we can do, had over 1,000 micrograms of fungi per milliliter, and the cheat is time, because it's material that was 14 years old. So there's no way, you know, for Dr. Johnson to be claiming that after 12 months you're not going to have any Hyphy, where you've got this wonderful material that's 14 years old and it's got more Hyphy than anything else that we've seen to date.
And can I ask, if it's got loads of Hyphy, how does the fungi still grow? Does it not need the spores there as well to actually sort of start fungi growing in a new trial plot or a new field or whatever?
Fungi can be a very large organism.
Grow from Hyphy.
Say again, please.
Pardon?
Was the question, will it grow from Hyphy?
Yeah, can fungi grow from Hyphy, or do you need the spores for the fungi to establish?
From what we understand, basically you can grow, but spores are a long-term survival for fungi.
Can you repeat that, please?
It can grow from Hyphy.
Okay.
And spores are a long-term survival solution for fungi. So spores can last, you know, thousands of years, and that's something that, you know, has been found in, I don't know, tombs of pharaohs, and then, you know, brought to life again. And then in terms of, you know, can it keep growing? Of course it can keep growing. The largest fungus, you know, is the largest organism on Earth is a fungi, and it's hectares in size, basically.
I just wasn't aware that you could cut a bit off, put it somewhere else, and it would regrow.
The one thing, for instance, that you can do with a mushroom that you buy from a store is literally you can sterilize a knife, cut a mushroom open, and sterilize the knife again, and basically just cut a little piece of the inside of the mushroom, and that is basically just a mat of Hyphy. You put that into a sterilized substrate, and you can grow out that mushroom.
Right.
If you were extracting from a compost, would spores not be a better option than Hyphy, or you don't, or both?
I'd say both are great. You know, especially, you know, spores are especially great if you know what they are, and you know, but we just don't have that, you know, knowledge yet. Hyphy are supposed to be already active. To be perfectly honest, you know, I must still say that I don't think any of us have the answers properly yet. The stuff that we would like to gather basically in the next year or two with DNA analysis should give us more answers, what we're actually, you know, working with. It's great. We have Hyphy. It's great. We have spores. What are they? So, you know, there's a lot of work obviously on species that's already been done. This might be helpful. If you have microscopy images of spores, for instance, that you have encountered, you can put them up on fungal microscopy group on Facebook. There's quite a few clued up people on that group, and I refer a lot of people to that group.
I'll be honest and say I'm wrestling a bit with the compost idea per se from a workload and a cost point of view compared to farmyard muck. The carbon nitrogen ratio seems to be fairly critical, and the easiest way or the most cost effective way for us to manage that, it would seem, would basically to bed the pigs up more often. In terms of finding and sourcing and paying for the ingredients, finding the facility to be able to mix the compost and monitor it, which seems very critical to getting the best results from it, and managing all of that and the extra handling and scouting and spreading, it seems to add up to a colossal amount of time and not inconsiderable cost. At the present moment, for all it interests me greatly, I'm a little bit sat on the fence and taking the view that straw and muck is a much simpler fix for us. Fix is probably a bit, it sounds like we've got something broken, and I'm not sure that we have. But that, by nature, putting more straw in, it creates more volume of muck, which can potentially treat a greater area. Not trying to play devil's advocate, more illustrating my experience, really. Just wonder what your thoughts are.
No, that's a great point. And we've been having discussions internally and with other people about, you know, the circular economy still having lots of gaps. And so, you know, there's lots of excrements out there, you know, that should be incorporated into, you know, growing crops in a proper way, in a safe way. And so, you know, or maybe even, you know, nutrients being extracted from it. If you think about it, you know, phosphorus is being mined in Morocco, but it's abundant in muck. So why is it that we've got this crisis of sewage sludge being pumped into the the waters around the country, where we're pumping all of that Moroccan phosphorus back out into the sea?
It doesn't make a lot of sense to the average common sense people like you and I, but that's boffins thinking different ways, it would appear. Pig muck fur is a bit more consistent than maybe cattle muck out of a fold yard, and it's already more chopped up by nature, so it's a bit easier to handle perhaps. The muck spreading rules in this country are going bonkers. That might hamstring some of our activity, and that might swing us more towards compost for what is currently a summer application for some of it, 3/4 at least of my muck goes on before spring crops, but there is some goes on in summer as well, and that's sort of where I'm thinking my focus on compost might be best placed.
Well, remember that compost can be made with muck, and you know, there are places around the planet which basically, instead of having massive lagoons, you know, in dairy operations, you actually have a composting operation beside it, and it's a mixture of a business decision and regulatory decision. I think there's a third solution somewhere there. There could be an entrepreneurial way to solve this problem for everybody, you know, somewhere between farmer and the regulations and the practicality of these things. I don't have that answer yet. I have seen some solutions, you know, again, around the world in various ways applied. I'm with you that these nutrients have to go back to the soil and have to be used properly, and are an easy addition to the fertilization regime. I also believe that soil microbes can help with cycling these nutrients. I also know that composting these nutrients can very quickly stabilize them, so that, you know, the environmental agency would not be having any issues with it. But yes, the practical side of composting, unfortunately, it is a hassle. And I think, you know, this is why my initial conversation with the Soil Association was that they were not promoting Soil Food Web, you know, generally to farmers, because basically, you know, imagine busy farmers getting their head around this. And I said, they're fair points. So that's why I'm starting, you know, from a business side of things, to be able to come up with a product. Compost has a nutritional value. To us, it's got a value of creating this mechanism that can, you know, cycle these nutrients and dig these nutrients from the soil. Manure has a place, in my opinion. It's as long as basically you've got a way to apply it, keep doing that. Composting to me is a way of getting those microbes that can do all that stuff, and unfortunately that bit is difficult.
It is. I mean, I think I've always thought that muck does more than it says on the tin, for want of a better way of putting it, and I think the same is probably true for compost. We had some timber harvesting take place on the farm. The timber belongs to the estate, and most of it went for wood chip, and there was more left than what would go on the transport. They left me a couple of cube, so I thought, well, there's my golden opportunity to mix some of that in with the muck heap and just see what happens temperature wise, and see what happens from the point of view of making compost of it. I had to find something to do with the wood chip, somewhere to put it. So I thought, well, that's a good opportunity as any, to try and mix them up. It's for want of a better way, trying to create some form of rocket fuel, but trying to level things up and trying to think, well, how do we balance compost against green manure, grown in the field rather than spread on it? Carry traffic probably better, it's less work. How do we quantify it? How do we put cost to each one? What are we trying to achieve fundamentally? We're messing about with cover crops here for 11, 12 years now, and trying to find non-chemical ways of controlling nematodes and things like that. And that's working reasonably well. The more I learn, the less I know. We've barely scratched the surface in terms of what's possible, I'm quite sure. Compost is of great interest, probably because of the history of the muck, and as a tool that we can probably better utilise our muck in conjunction with the ridiculous rule changing of the muck spreading and what's actually possible. My concern is that we lose some, particularly nitrogen, that could have been feeding the crop to create the compost, and which makes the compost less fertile. And that might be me looking at it through very simplistic eyes, and I might be completely on the wrong track there. And that's kind of why I'm here, to learn about this sort of stuff, really.
I think Jonathan wants to add something. He's shaking his head right now.
That will suggest I've got something wrong.
No, it's not so much that, guys. It's really interesting conversation, but it's really, from my perspective anyway, that what often happens is, if you've got a relatively impoverished soil to start with, from the point of view of whatever soil type you've got, because you can't really change that, and your carbon nitrogen ratios might be a bit out of kilter, you've got to be so careful, because I have a big argument stroke debate with the local estate all the time, because they put the straw into the compost, I think wrong, straw into the muck, don't actually assess what the carbon nitrogen ratio of that is before it's applied. And the same with the soil. If the carbon nitrogen ratio of the soil's out, all you're going to do is just totally absorb all your nutrients into the soil, and it'll take years to get the benefits. So I would suggest by all means put straw, wood chipping, and anything, but particularly if you can get it for free, but just really allow it to cook off in a heap, in a safe inverted commas environment where it's not going to leach before you actually put it on. Because excuse me, I'm up next week to an estate in Scotland, and they've got quite a bit, I wouldn't say wrong, so it's insulting, but through either misinformation or misguided thoughts, that they've stalled their soils basically, simply because, as I say, you've got a sort of a sandy loam, for instance, with a relatively low cation exchange capacity already. Microbial activity isn't very good for whatever reason, probably historical. And then you've chucked a load of carbon in there with the straw and the muck and then wood chipping, and it just sits there, and the crop virtually can't access anything until the microbes can catch up much later in the year. But hopefully that makes sense to everybody.
It does. I mean, you mentioned that out of kilter and levels being wrong. I think some of that is knowing what those levels need to be, and where the danger levels are. And I don't think that's particularly well advertised. I couldn't tell you the figures off the top of my head. I'm as guilty of what you've just described as anybody else, although we tend not to be. This is the first time we've had wood chip to you, so she's a little bit new. And, I
wouldn't say guilty is being very harsh, but I know what you mean. I understand that the concept, because the thing is that the microbial activity, as in the beneficial guys we want in the soil, they want about 24:1 carbon to nitrogen ratio, but within that 24, there's a good 16 parts of that massively fluctuates depending on the time of year, temperature, their activity, their needs. So you've got a bit of a baseline microbial level of roughly 8:1. That's just the structure of the microbes themselves in the soil. So if your carbon nitrogen ratios in the soil, when you assess them, and bearing in mind it will fluctuate depending on time of year, are about 10:1, they're going to be reasonably balanced, because as I say, there's just a huge labile pool that just keeps getting used, lost, used again, and just keeps going round in circles. And then obviously at this time of year, when the temperature starts dropping, even though soil temperature is still about 11 degrees C at the moment, which is slightly unusual, but there we are, there'll still be some activity. But that's the crucial thing to consider. And then if you know what your carbon nitrogen ratio is in the soil, and you know what the carbon nitrogen ratio is of what you're putting in, you've got a better idea whether you're overloading the soil, stalling it for the benefit of crops, or actually feeding it.
Where would you say danger level is then, Jonathan?
Well, to be honest, if you start getting down to 8, you definitely haven't got enough microbial activity, because the soil's gone wrong. But personally, start getting up to 11, 12, there's too much carbon for the soil, and it often relates to the soil type. So, as I say, we can't change what we're given, but if you've got, old money sort of light soil, your sandy loams, you really don't want to be going much above 10 or as 10 to 11. Definitely not much above that. If you've got more of a clay-based soil, then it could probably tolerate a bit more, because inherently you'll have more microbial activity from a clay-based soil. So it's not a definitive guide, but there is so much, marketing bollocks, for want of a better expression, but all the ag chem companies, I'm a sort of scientist and agronomist, by the way, all the ag chem companies are just jumping on the bandwagon of soil science, but using it to just sell something else. And misinformation might be a little bit harsh, but there's a huge element of disingenuous behavior because they've got to make a living, which is fair enough. So yeah, hopefully that makes sense. But there is just so much, just misinformation, really.
Yeah, that's the difficulty, trying to sieve out the relevant and useful bits. Minus the marketing BS.
I know. Well,
cross that with the cost of the job. Try and make the right decisions.
I couldn't agree more. And this is the whole thing as well with cover crops, because if you fundamentally you need something that's going to produce nitrogen, something that's going to restructure your soil, something that, as in a graminease species, it's going to interact with the arbuscular mycorrhizal fungi, because those are the guys that really, really promote and release nutrients from the soil. And if you've got those three things as a minimum, that will then be cost effective. And if you think about it, you might have some rye, for instance, that generally grows anywhere, like struggling, huge deep roots, goes down about 1.5 meters. Maybe some forage peas or anything that's just lurking about you can put in. So it can be done relatively cheaply. Or one of my favorites is vetches, because they're leguminous in their own right. They've got their whole biomass is about carbon to nitrogen about 11:1, so absolutely invaluable. But they can tend to do too well. I mean, it's good, but you end up with a lot of biomass above ground, so you do need sort of crimper rollers or something like that to really try and destroy the cover early, so that you can really get a bit of frost on. Because I've got some photos somewhere, but I'll never be able to find them, of just how staggering the benefit of just rye and vetch is to soil aeration, microbial activity, just the whole. You can lean on the soil after rye and vetch that was completely compacted all winter. Lean on the soil with your finger and it will just slide in. It's staggering. So you don't necessarily need a huge number of species. It's brilliant if you can, brilliant if you can afford it, because obviously that'll increase the biomass, the biota in the soil will love you for life. But there's got to be a cost benefit to everything, fairly obviously. And spookily, farmers are actually trying to make money and make a profit and improve the soil structure, health, fertility, all of the above. And you say it's quite tricky sometimes getting that balance. But all I can say is, if anyone wants any sort of independent advice, just give me a shout, because I lecture on agriculture up to master's degree level as well, and I'm constantly fighting a uphill backwards half the time, but I'll keep shouting loudly.
You'll keep doing that. It's interesting you mentioned rye and vetch. I have some of that before some spring oats this time. Some end of the first week of September after some fairly late wheat. Looks decidedly unimpressive at present moment, but I've long since taken the view that there's more goes on underneath the soil than what goes on above, and that's the important bit. So I'm watching it with interest. What my next level of thinking with some of my cover crops is trying to learn at what point nitrogen fixing elements of those covers start fixing usable nitrogen. Which ones can do that without having to roll it or otherwise hit the surface like you do with some of the clovers? Mm-hmm. And at what point is there a nematode effect, either positive or negative? With potatoes on some following overwinter stubbles on some farms, which is the bane of my life. We do far more cultivating after overwinter stubble than ever we do after a cover crop. But they harbour things like groundsel, which is creating us some free living nematode issues. So where I can put a cover crop in, I'm trying to mitigate some of that damage, if you like, because we're only a snapshot in their farming system. We've only got that land for 1 year. At what point? What are my best choices for cover crop elements to control nematodes, but not put something in the mix that will negate that by making it worse? And where can we fix nitrogen from a companion crop point of view and from a cover crop point of view? as I said earlier, the more I learn, the less I know, and we're only just scratching the surface of what's possible. It's all quite exciting.
But the crucial thing is the crucial thing is that you're actually asking questions of what you do, what you want to do, and that's 90% of the battle. Have you tried sort of black nightshade and things for reducing nematode populations, or?
I haven't, but that's more down to as far north as we are, and it essentially takes out a year's production. We know
whereabouts are you?
Sorry,
whereabouts are you, ish?
I'm a tenant farmer on Castlewood Estates. I'm halfway between York and Scarborough.
Oh, right, yeah. Well, I'm only down at Beverley, so.
All right, not so far away.
No, but I understand the environment in your world, and the only thing I would say as well that it might be a bit late in the year, September, to be putting vetch in. Ish, they prefer it earlier, slightly warmer to get away. So it might, when you're looking at it, thinking, "Come on, sort your life out," might be a bit steady still, but it is relatively mild. So yeah, it'll be what it'll be. It's in the ground, so it's job done.
That's what I mean. Radishes are the interesting thing to us.
Yeah.
Choosing the right mustards has taken me a long while.
Yeah.
It'll take me a long while to learn what not to grow, which I think is important as what to grow.
Yeah. Just to interrupt on that one. Sorry, just to interrupt on that one. While you're talking about mustard, it's really interesting. Well, everything's interesting to me, but if a cereal or gramineous species goes through the soil and encounters a compacted layer, so thinking about using cover crops to restructure soil, the tip of the root, when it encounters a compacted layer, produces ethylene, because the root will be wasting energy trying to get through the soil. That then stops the root growing downwards and then goes sideways. The only thing that can just keep pushing through, because it doesn't give a tinkers, it is mustard. But as you say, if you're not careful, you get such a huge biomass above ground that it's nearly negated any benefit you might get below. But other than that, mustard hasn't really got any uses.
The one thing that we have seen sort of like in just observations, but on a very, very, very small scale, is that a very high amount of fungi will stunt mustard growth.
Okay.
And so this is where this whole thing about succession comes into play. And this is something that we would like to basically see if there's, what is required, and how long it's going to take, a farm scale application to get to the point where, we can bring the fungal populations to a level where, growing a row crop, basically, you could have a mustard, cover crop, but it's gonna be this tall, basically. It's not gonna be taking over. So there's mustard, basically brassicas, they don't do very well in fungal dominated soils. Brassicas, for instance, they don't have any mycorrhizal associations. They actually get damaged by mycorrhizal associations. So they have to be grown with actinobacteria, something that it's usually you can find it in the soil, but you can add to it as well if you want to. But yeah, it's this whole thing about succession, microbial succession, is something that we would like to see more of. See how difficult it's going to be to push it, and how much of it do we actually need to be able to see those effects? Is it something that we can do with the applications of that Hyphy, like we spoke with Judith in the beginning, the applications of Hyphy and spores, like Andy was suggesting, or are we going to have a mulch layer of 15 centimeters of aged wood chips, with King Stropharia growing through it? We don't know. So this is something.
Fascinating questions.
Sorry?
So fascinating questions.
We have more questions than answers, to be honest.
Well,
I had a
know the
chat. I
feeling.
had a chat with Mark from Velcourt just before this meeting, and you know, he said that in the last meeting he was a bit late. He wanted me to give him a bit of introduction, and I think I just spent 10 minutes just saying, like, you know, how many questions we want answered, you know, over the next year or two, just working with this biology. And you know, we've got reasonable amount of evidence to say that that we should progress, and we want to progress, and we want to basically, you know, answer those questions, because otherwise there's no point. Yes, the questions range anything from, you know, the modes of operation of these microbes, the survivability of these microbes, to practical questions like how do we apply these things and make it survive. So, and then how it, you know, how it behaves. So, you know, we need definitely to work together, you know, with people like yourself and other agronomists, you know, who are on, you know, on how.
Always glad to help with that if I can.
That's great, you know, because we don't really have any experience with you know, with cover crops or anything like this, but we know that cover crops will be essential to support these microbes over the long term. And so, you know, how do you incorporate that into the system? How can we sort of put it all together into a working system that will simply, you know, replace everything that at the moment, you know, is an agrochemical input, but then doesn't become more expensive than the current system, because then it doesn't make any sense. So yeah, this is, you know, lots and lots of questions. I still would like to go back a little bit to Andrew's question about, do I make compost? You have to answer the question why you're making compost. Like, why is it that you would be making compost? You know, the simplest answer for any farmer would be, well, there's nutrient in it. Okay, well, yes, you can quantify that. So, you know, you will be able to quantify that. And yes, you can use manure again as an input, and the composting process as a means to stabilize that nutrient. You don't necessarily lose it if you do it properly in an aerobic system. You stabilize it into the microbes. And so, you know, it's like a slow release fertilizer then. But I think in terms of making compost as a nutrient, it has to be a solid calculation, you know, like this is how much it's saving you in terms of the fertilizer. So for any farmer who's making their own compost, you know, without even thinking of the soil food web elements of it, it probably would be worthwhile then to say, okay, well, let's do a trial of, you know, 100% fertilizer, 80% fertilizer, 60% fertilizer, 40%, you know, this kind of trial on a small scale to see what effect of that homemade compost, you know, is on your inputs, and can you save money on it? I think that's basically what you would need to do if you are doing this yourself. And then there's the thing about the soil food web, something, you know, that we're trying to help with. So not many people get the full soil food web when they're making compost. We did show in the first meeting, you know, the results that we've been seeing across the board, and we seem to be seeing that, okay, well, there's bacteria usually in decent numbers, not going sky high like in the soil which has been abused, but in reasonable numbers. And then we see protozoa, some nematodes, and very little fungi. And so if we're talking about controlling that mustard situation, that compost won't help. But what it will help is if the protozoa survive the process of delivering to the plants. Okay, that's a caveat. If they survive the process, they provide nutrient cycling. So they will take the bacteria that are already in the soil, they already have some nutrient in them, or the bacteria that are in the compost and have nutrients. And if everything is happening now around the plant roots, they will release those nutrients. That's one of the modes of releasing the nutrients from the bacteria to the plants. But one of the questions that we need answered in a very solid fashion is, how do we apply these microbes to the soil, to the roots, in a way that they survive? What we've been doing here on the winter wheat, we now have been successful in establishing bacterial and fungal feeding nematodes. So we're very happy about that. But flagellates are very vulnerable. If we just spray the flagellates onto the soil, especially on a relatively warm day, we have not had much success with keeping them alive. So we need a mode of, injecting them into the soil in a manner that makes them, gives them a chance to survive. There's one of those questions to answer when it comes to the soil folder. But yes, compost, nutrient values versus how much you can save. That would be my advice on that.
That all sounds very interesting. Certainly trying to get the flagellates to survive and what not to do if nothing else. I mean, that's sort of invaluable information, isn't it?
What we're trying to do right now, we're actually just doing a little test. We're trying to encyst flagellates. I think it's going to take us a few iterations of with a few different species, the ones that we encounter. See if we can encyst them first. And then when they're in this form, they can survive much more. Because I have tried it. I've put a fluid rich with flagellates, put drops on a piece of glass, left it overnight, dried to nothing, put it on the microscope. 0 cysts, 0 flagellates, everything drops. So they have no chance of surviving. Right. Just to drop them to dry out.
Yeah, at the moment we're running an experiment which is a 6-day, and I've just seen today a decrease in number of bacteria and small flagellate, few cysts, not many, but it's still quite big flagellates. So it takes time. And so we still don't know how they behave.
Yeah, we've got a couple of ideas basically that we're trialing at the same time. Basically, what is going to be a good method of encysting. So we'll then basically come up with a product that will be selling and contributing to my pot for buying my own fighter jet. But until then, we need to do more work. Cool. It sounds like actually, this is 5:15, and we've actually had a good bit of it, more of a technical conversation. So thank you very much. I'll just give you an update now quickly on what I'm trying to do basically with the trials. The plan is still, we need to build a consortium of farmers who want to run trials, and I really need to do it in a way that is not some sort of a bank breaker for the farmer. Please bear with me, but I'm hoping that you can participate in the trials. You will sign up for the trials. The idea is that we're going to have University of Sheffield and NIAP on board. University of Sheffield will deal with the DNA analysis, and NIAP will deal with management of this whole thing and making sure that everything is done correctly. I'm speaking with NIAP tomorrow about this. What I want to basically design is something that it's either going to be small scale if we can't get the grant or investment, so that the farmers don't risk too much and they don't lose money unnecessarily, or the larger scale projects that we want to do, like the 5-hectare biology, 5-hectare control and whatnot, is something that we'll need to have sponsors for. I do believe that there are some farmers where the farm is large enough and the owners might have some money in their pockets to put up for it, and I would be grateful if anybody stepped up for that.
Just ping us an email, and I've just got a couple of thinking souls that might be up for that.
Okay, I'll do that, John. Thank you. So what I need to do basically is, until the next meeting, basically, I need to come up with like 3 different tiers of trials: tiny ones, small ones for people who, anybody who can afford that, and larger ones, something that we'll probably have to get sponsorship for. And so what we're going to be doing is we're still going for a grant, that DEFRA grant. The success rate of these DEFRA grants are like 5 to 10%. So I'm really, it's
proverbial rocking horses.
But I'm also going to be turning that grant application into a kind of like a pitch deck, for restructuring this whole company, so that we can bring in more of a business arm, something that investors like to see, and something that will free me to work on the R&D as I prefer to, and also bring in the funds to cover the costs of Sheffield and NAB in case we don't get those grants. So this is my plan right now, and I'll be working on this over the next week, basically, and hopefully next week I'll be able to present you a bit of a better plan and start signing up people who can say, okay, yes, I can fit into that slot. Yes, I can fit into that slot, or yes, I can, take on the bigger one. It's not going to hurt me that much even if I lose the control on 5 hectare thing, So what we're trying to do, obviously, we're trying to make it sensible. We want this to be an economical proposition for everybody.
Yeah,
so
well, I mean,
that's me shutting up about that, basically.
I know it's all as far as I'm concerned, it's all good. Hopefully, I'll be able to get back next Wednesday and hear what you have to say.
Super, not a problem. I'll just double check that. I know I've got your email. I just make sure I've got the correct John and
Lordington Park Agronomy, so it should just drop in.
I've got one at hotmail.com, J Holmes. Yeah, I've got that. That's no problem.
LPA, yep.
Super. Excellent.
Yeah, just let me know how I can help. I'm sure I can dovetail somewhere and get people in the wider world involved.
I will do. Thank you very much. I'm just making a note for myself.
That's right.
Yeah, super. So yeah, in terms of our world, the guys actually today have been looking at preparing also an offering to gardeners. This is something that Rob and Damien, you might be interested in, because we pretty much have a product that could start going out to the smaller growers, indoor growers as well. So they've been very excitingly putting together products that we can start selling. So within the next month or so for smaller growers.
Big demand for that. Big demand.
Yeah, I mean, if we can help, we'll help, because it's going to help our, ability to pay our salaries. So that's important. Because
crucial.
we want to make all these trials. We need to at the same time we need to survive. So that's one way of doing that. The what we're hoping to do basically is this whole soil thing. We just want to make it easy to use for farmers as well. So we've managed to get to the point where we've got this concentrate, we can drop it into a sprayer and off you go. One of the questions that we need answered, and one of the painful realizations I had since last week, actually, and I have to be honest about this, because last week I was saying that I'd like to have 50 trials across the country, large scale, 5 hectares biology, 5 hectares control, 5 hectares conventional. If we get the grant, that would make sense, by the way. But the practical side of things is that I don't know if we're going to find the equipment across the country that is capable of injecting this biology into the soil effectively in every part of the country where we want to do this trial. And so that's a major concern now. So this is something that, we have to answer alongside, developing the biology. We have to also answer the question of how do we put it into the right place. And some of you have already been modifying your equipment to be able to do that at your own cost. I've seen the I think it was another Jonathan that was sending me pictures actually 2 weeks ago. How he modified his drill to be able to inject behind the drill. That's one way of doing that. My colleague in Jersey, Glyn, had a farmer modify his ripper to have a tube behind the ripper, and basically they just drilled holes, and when they found that they did drill too many holes, they just put screws in half of them, and they were able to control the flow. But all of that work will take time, and I just have to be real with my own ambition here. So we'll have to make sure that that we can deliver on these plans. I wonder if Rob and Damien are listening right now, thinking to themselves, we've got some thoughts about that.
Yeah, absolutely. Hi, Daniel. Hi, everybody. I actually was making a cup of tea when you actually said, and then don't know my name, and I thought, what was that? So I was listening, but Well, just go back to the bit you said you thought we'd be interested in particularly. And
We're just basically preparing an offering for smaller scale growers as a product.
right, is it an inoculation and like a?
Yeah, basically like a whole thing that, you know, it's going to come as a kit and it's going to be very easy to use.
And is that a dry mix or a wet mix?
Bit of both. So we've got basically a sort of paste, and we also have got a dry kind of fluffy thing, and also a bit of compost with some more flagellates in it. So kind of a kit that you can use for everything. But it's still in the works. It's something that's going to be ready maybe the next couple of weeks, 2-3 weeks. We're going to start maybe doing something with that. So yeah, it's not ready yet. It's just something that we're preparing. But we've got the main ingredients. Everything is there, and we'll be able to you know, put a batch number on it and what are the numbers of microbiology in it, and so we can vouch for it.
An area we're particularly interested in is seed treatment, or if you like plug treatment, i.e. a module plant.
Mm-hmm.
Whether there's anything there, so a very small amount put in at the plant at the plug stage. Be particularly interested in strawberries, as you know, I'm a strawberry fanatic, but be interested to see what
we know.
And possibly other indoor crops like tomatoes as well. So I'd be very interested to see that.
Yeah, for sure. We'll be in touch.
There's a lot, and we could talk about more. It just get. I think there's a lot on this trials area. I think there's a ton of people we know as well that could be useful to get some volume to this. I think what you're doing, Daniel, is fantastic. It's such a great group of people you've got as well. So I'm just enjoying listening, to be perfectly honest. It's fantastic what the people you've got here.
I agree. It's good to see that, you know, this is this movement, you know, sort of coming from the farmers, you know, that the people are trying to solve this. There's obviously this pressing issue about the cost of nitrogen fertilizer and the future of that. And nobody really's got an answer for it yet. It seems that, you know, the farmer on our farm, basically the current plan is don't buy fertilizer, and you know, see how we're going to deal with that. He's in a fortunate position that he's got a green waste composting site, so he's just loading up the compost on his fields.
Yeah.
And whatever nutrient is available in that is basically, you know, going to be available to the plants at some point. We're trying to help him as well, in the sense that it just happens that the newest pile that he's building is just across the road, which means that we don't have to go very far across the fields to feed it with our biology. So we're going to basically try and get a massive pile of his compost inoculated with our biology and growing through it. So you know, there's going to be lots of material to work with. We're sure of that. And he's going to be able to use a lot of it, and hopefully we're going to be able to see the benefit, but we're not going to see it until the end of the harvest of 2022. So
okay, it's a long game, farming.
it is it's teaching me patience.
Thank you.
Super. And Judith, I saw your trial idea, and Janice commented on this as well, Dr. Lake, and from Sheffield, and it's a great idea. It's something that it could be very practical on that fertilizer front. So and just to say here, what Judith proposed is 4 plots, their own treatment, biology treatment, control, no treatment, and a mix, fertilizer and biology. And we believe that this is something in the interim where we don't have all of the data that we need. This is part of gathering that data. And so it's possible, it's differently. Some of the trials that I want to basically design is I want to design on the gradient of fertilizer inputs. Basically, you know, see if we can simply increase the efficiency of the synthetics in the short term. So our long-term ambition is to have a system without synthetics, but can we help in the short term is something that we want to answer.
Yeah, it's
so
a transition.
Mm-hmm.
It's a transition from one to the other that's important at this point in time, isn't it?
Mm-hmm. So this is, your idea about, having that that mixture is actually something that we will incorporate into the trial design, and we'd like to gather that data.
It's also easy to manage, because it's kind of a bit of what I've done on farm already, because you just do half the field with your biology that way, so to speak, given if your field's a rectangle, and then do half the field that way with your fertilizer.
Oh, there you go.
And
I see what you mean.
easy, because then you've got your 4 plots, and it's not difficult to work out if to do it that way.
But this is this is something obviously for you to do on the pasture. If we're working with arable farmers, it's going to be down the tram line.
Yeah.
So we'll have to design it bit differently. But I see now your logic about doing this in a square.
Yeah. Yeah.
Gotcha.
When you're talking about application, like in our situation on a grassland farm, I mean, would you still be putting it in down a slot, or would you be using something like a dribble bar rather than a sprayer?
So a slot would be useful. There isn't many yeoman's plows in the country, unfortunately, which is something very popular in Australia. It's an Australian what's the word, tool. But basically the yeoman's plow is like a deep ripper, but it's slightly different in the sense that there is no big hoof. It's just a bullet. And so at the bottom, and so it acts like a knife. It just creates a slit, and then there's a small crimper behind it that closes the slit. And so the damage is basically minimal, but it allows the injection of the biology deep into the soil and breaking any compaction that you've got. So that's an ideal situation for us that we'd like to test, to actually have the biology down where it needs to be.
So sorry, Daniel, what was that delivery system called?
It's a yeoman's plow. I'm just going to actually type it in the chat so you can see it.
Thank you. No, that'll be good. So that's
and it was a guy called Yeoman that designed it years ago, probably in the 60s now. And this was about places like Australia, which are very, very dry, and they were all doing this on contours so that you could capture water. So one of the ways was either to rip on contour, or to have ditches on contour, and then planting trees on the berm side of the ditch in an agroforestry system. But for pastures, basically, it was all about stopping runoff of water, capturing as much water as possible. So that's why they would rip on contour. That's the whole yeoman's plow playbook. Yeoman's playbook is, he wrote a whole book on that, just ripping on contour.
What kind of depth does it go to?
Say again, please.
What depth does it go to?
These plows are not that deep, actually. They're about a foot and something, I reckon. They're really not that deep.
I think it's a bit deep for us.
Is it?
We're what we call near the rock.
Near the rock. So you'd be scraping on the bottom, basically.
I think the tractor might be up in the air. but yeah, I'll have a look. But I mean, even our old clay tiles are not deep.
Mm-hmm.
And we really struggle now if we're wanting to get contractors in to do work. Well, we've had to change our contractor for spreading fertilizer.
If you're sitting on rock, don't bother about ripping.
Yeah, I mean, a dribble bar for me would make more sense, I think.
As long as the dribble bar basically to me makes sense as well, especially if we can incorporate some organic matter at the same time. So basically, the tanker is basically filled with the biology, but with compost, with sieved compost, for instance, that's already been mixed in.
Yeah.
Because then basically when you're putting out, it's not just the microbes sitting on the surface of something and being exposed to the elements, but they've got some
nutrition to go with them.
Some safe space, I would say.
Right. Okay.
More than nutrition as well, but safe space as well. So this is something that I think, Adam, are you wanting to say something?
No, I just saw Andrew's comment. He said that the yeoman's plow looks very much like another tool that I've never heard of, but we should look into.
Cool. Shakeator.
Also, Judith, we just drawn up your little intersecting idea, and it looks very much like tartan.
So it's a
Kind
nice
of,
touch
yeah,
from Scotland there. Yeah.
Yeah.
Nice touch.
Yeah.
Yeah, the Shakerator was very popular, wasn't it? It basically it's a subsoiler connected to the PTO, and it shakes the living daylights out of you and the soil it goes into. So it's a lot deeper though than the yeoman looks like it to me. Anyway.
Yeah.
Mhm.
The yeoman is a passive tool. It just basically runs through the soil like a. It doesn't. It's just a little bullet. It's literally the size of my hand, like that.
Tell you what, though, it would make a better job if it had a PTO on it to shake it around like the Shakerator. It improves it enables you to go deeper. The whole point, it has a agitation, so it breaks things up. It's like when you cut anything, the vibrations make it easier to pull.
Oh, that's interesting to know. Yeah, because any time you're ripping deep, you need a big tractor, obviously.
Yeah.
That's
you can turn off your PTO when you're doing it, and you feel like you've thrown an anchor out the window. So it makes a big difference.
Wow.
Yeah. And are people injecting stuff with it? It looks like they are online with the yeomans.
Yeah, I mean the yeomans doesn't come naturally with an injector, but a lot of people modify it to be able to do it.
Yeah, I can see that.
Jill has asked a question on the thing. How do you propose smallholders, gardeners spread material? On surface, basically. Smallholders, gardeners are best with no dig methods. And usually if you dig stuff in, any kind of disturbance actually is worse than actually keeping a good mulch layer on the surface, compost layer on the surface, because you can afford more material. So having good compost and having the biology in the compost. So one of the things that we'll be offering, the goopy thing, the extract of microbes. This is something that you could also potentially grow out in a bulk bag of green waste compost that you can buy from any local green waste place. This is something that we discussed earlier. So you could buy a bulk bag, you could buy our goop, you could put it you could put it in a watering can, put it into the bulk bag, and in 3 to 4 weeks you should have that growing through it, and then you can use that to put on your garden. So that could be an expensive way of getting the good biology onto it. So yeah, don't bother digging it in, keep it on the surface. Cool. Any more questions before we finish? Because we're starting to overrun. Andrew Wilson, good description. Rob, yeah, there you go. I remember pulling a 7-leg Shakerator with a 90 horsepower 4-wheel drive tractor as a student. Stopped the PTO and I couldn't pull it. Harvest 1995. It was dry time. Yeah, thanks for that.
I was probably doing the same thing at the same time.
I use the same, and we always did it on the tram lines. So it's after all the tram lines, just followed it up. Just went around each paddock and just each paddock, Kiwi term, around each field, and away you went.
There we go. Super. Any more questions?
I've got one, just a sort of maybe for next time. My experience with biology is that it doesn't necessarily start working until the soil temperature warms up. And Judith was talking about doing a mixture of fertilizer and biology. What we have found is that putting the fertilizer on early in arable crops helps hold tillers and keeps the crop growing, and wait until the biology gets going. I'm just curious how you think going fully biology, you're going to negate the early yield tiller loss when the soil is cold in sort of February, March. It could be a challenge. I'd be interested to know your thoughts on soil biology not going quick enough compared to. You understand what I mean?
Yes, I do understand what you mean. There is a sort of activity curve profile throughout the year. and usually the nutrient cyclers are not as active in the colder period. It's usually fungi that's active in the colder periods. So like in natural ecosystems, you're going to have the fungi growing through the autumn and winter, and then when the soil starts warming up, you're going to have microarthropods and other things starting to chomp them down and actually eating, the hyphae. So this is something that you're absolutely right. But in terms of answering that question, how we're going to deal with that, you've just added to the long list. So thank you. Any more questions before we finish?
Great job, Daniel. Well done.
Super. So thank you very much for this week's session, and hope to see you next week. And next week I will come up with some better selection of trials, and be prepared to say, yep, let's start signing up to this. Which one makes more sense to you? And we can build the consortium properly in preparation for the grant application and everything else. So I really appreciate you being here. Thank you for your time. See you next time.
Thanks, Daniel.